Okay, last video I talked about orbitals and what it means for something to be an orbital and what that means for where the possibility of electrons could be. Okay, we're going to take that one step further with this video and talk about, okay, if these orbitals are present, can I now start talking about individual atoms and where their electrons are located inside of that atom? Okay, and the answer to that statement or to that question is yes, we can locate where each electron is for each atom based on where the atom is located on the periodic table and how many blocks or orbitals it goes through. Okay, so if we were to look at the back side of this on page 80, okay, we're going to start talking about electron configurations. Okay, now in the past you've dealt with something like Bohr, where you would say, if I have a lithium atom, let me pull this down. Sorry, if I have a lithium atom, I know that lithium has 3 electrons in a neutral species. How do I know that? Because its atomic number is 3, which means that it also has 3 protons. Okay, so I'm going to need the protons and the electrons to cancel out in this case. So if lithium, if I was to draw a Bohr model, if lithium has 3 protons inside of its nucleus, the first ring in the Bohr model will hold its 2 electrons, where the third ring will hold its 3rd electron. Okay? And this would be the Bohr model for lithium. If I was to take this one step further, I could say how many valence electrons lithium has, right? If you remember this. And if you remember, the outermost ring specifies how many valence electrons there are. So in this case for lithium, since there is 1 outermost electron, lithium would have 1 valence electron. And this is also really nice because if we look at our periodic table, if you remember, lithium is in group 1, which means that lithium is going to have 1 valence electron. Okay? And electron configurations make this very clear for us when we draw them. Okay, so let's talk about what an electron configuration is. Okay, electron configurations are the ways in which the electrons are arranged in various orbitals. Okay, so now we're going to talk about not just a ring, but the space in which the electrons are taking up. Okay, so if I was to flip back to my periodic table, I moved helium over here, and since hydrogen and helium are sitting in the S block, and they're at the very top of the periodic table, this is going to specify that these 2 atoms sit in the 1s orbital. Okay. Now if I move over, there's no p aligned with this 1s. Okay. So I'm going to drop down now to where lithium is. And lithium is going to take up the 2s, and I'm going to count. If you remember, each orbital holds 2 electrons, right? So I'm going to count 1, 2 electrons in the 2s orbital. Okay. Now if I was to go over on my periodic table, I do now have a p row. Okay. I didn't have one in the 1 energy level, but now I have one in the 2 energy level. So this row would be specified as 2p. And I would count 1, 2, 3, 4, 5, 6 electrons inside of the 2p orbital. Okay. And I'm just going to keep going. Okay, I have 3s, 1, 2, 3p, my 6 electrons, okay, and then I'm going to go to 4s. All right, now I'm running into my D block, right? Here's my D block. D is weird. It doesn't start at 4 where you would think it would be. It actually starts at 3, okay? So 3D would be the first energy level that D starts at. However, when I come over to a 4p, it will be there. 5s, 4d, 5p, 6s, 5d, 6p. Okay, and that's probably as far as we would have to go. Okay, Mrs. Stoser, you're writing these things on my periodic table, but I have no idea what it's for. Okay. Each letter and number that I'm writing represents an energy level where those electrons will be located. So if you remember that S is our sphere shaped, each electron that's located over in this s orbital is going to be in that energy level. Meaning, if I'm talking about potassium, potassium's outermost electron will be located in this 4s orbital, okay? And we can write these things called electron configurations to show where each electron is located, okay? So let me flip back to this back side. There's a couple of things that we need to know, though, before we start filling electron orbitals up, okay? And these are the 3 rules. Electrons always want to occupy the lowest orbital of energy first, meaning if I have a 1s orbital available, the first electrons will go in the 1s orbital before moving up to 2s, before moving up to 2p, etc. Okay? Each orbital can only hold 2 electrons. I feel like I've drilled this pretty hard, but just remember that. Okay? And then electrons will always spin in the same direction before they spin in opposite directions. And this kind of makes sense, right? Because electrons carry negative charges. So they're going to want to be spread out before you start to put them together. Okay? So let's look at these rules. For instance, for Hund's rule. If I'm talking about a 2p orbital, right, you remember our shapes for our 2p, there's 3 of them. I have one that's on the x-axis, the y-axis, and the z-axis, okay? So each electron will fill up x, y, and z before they start pairing up again in the x orbital, right? So 3 separate. If I had a 4th electron, that 4th electron will come in and spin down, okay? So that's electron configuration. So let's do some examples, or look at some examples for electron configuration. Okay, let's look at carbon. So if I look at the periodic table, carbon has 6 protons, okay, which indicates in a neutral species it will have 6 electrons, okay? So when I'm writing electron configurations, I always start with the lowest energy level first, okay? So I'm starting up here with 1s, and my goal is to get to carbon, okay? So how many electrons will sit in the 1s orbital? There's going to be 2, okay? This number represents the energy level, this number represents the orbital, and this number represents how many electrons are inside of that orbital, okay? So there's 2 electrons inside of the 1s orbital. There's no 1p, so I'm going to drop back down to 2s. So I'm going to say 2s. How many electrons are inside of that orbital? 1, 2. So I'm going to write 2 electrons. Okay? I have to keep going. And now I'm going over to where carbon is. Okay, so carbon is now located in the 2p energy level. So I'm going to write 2p. But it only takes 2 electrons to get to carbon. So I'm going to write 2p2. Okay? Now, this is a little bit different from Bohr's model because now we're not just talking about the rings where the electrons lie. Now we're talking about where is the energy, or what energy level are the electrons holding in. Okay? So this would be the electron configuration for carbon. Okay, now let's kind of make a note here. How many valence electrons does carbon have? If I was to count my rows, it would be 1, 2, 3, 4. Okay, but I have all 6 of carbon's electrons here, right? Carbon's valence can be found by saying 2 is the outermost energy level for carbon, and if I was to look at both of those electrons, 2, 4, that would be what tells me where the valence are for that atom, okay? So that's the electron configuration. The second way that we can show this is orbital notation. And orbital notation shows us how the electrons spin, okay? In orbital notation, we actually draw lines to represent the orbital, okay? So in this case, I'm going to draw 1s with a line, 1 orbital for 2s, and then how many orbitals does p have? I hope you said 3. So I need 3 orbitals for p. Okay. Now, since I have 6 electrons total, I have to fill in with my rules, remembering that electrons fill with the lowest energy first and then move up, okay? Meaning, I'm going to go 1s, 2s, spin up, spin down, 2s, 2s, spin up, spin down, and then I have 2 electrons inside of the 2p orbital. Both are going to spin up because they don't want to be close to each other. Okay? So that's our example for carbon. Let's look and see if we have anything else. So if I was to look at the electron configuration for hydrogen, it would tell me that hydrogen has 1 electron. And where is that electron located? It's located in the 1s energy level. Okay? Helium has 2 electrons. Where are the electrons located? The electrons are located in the 1s orbital. Lithium has 3 electrons, 2 of them located in the 1s energy level, where 1 of them is located in the 2s energy level. Okay? So that's kind of the biggest points that I want you to get here. Let me see if there's anything else that I want to do. Nope, that's it for now, and then we'll do some practice in class. So make sure if you have any questions that you're writing them down so we can answer them. Thank you.